Alright, so we're beginning analyzing sample final exam. Let's start with question 1. Which of the following would be best considered to be an agency conflict problem in the behavior of the following financial managers? So remember, agency conflict occurs in a situation where the person owning an asset is not managing it, or the person basically paying for something is not making all the decisions. They have to hire an agent to decide for them, and the conflict, of course, is that the agent may have different incentives than the owner. Okay, so let's go through those examples and see if they indeed are examples of agency conflict. So the first one is Michael chooses to enhance his firm's reputation at some cost to its shareholders by sponsoring a team of athletes for the Olympic. So this is not the type of agency conflict decision. The decision that the manager takes costs something, of course, but it's supposed to improve the PR of the whole company. So it seems that his goals are aligned with the owner's goals. The second one is James ignores an opportunity for his company to invest in a new drug to fight Alzheimer's disease, judging the drug's chances of succeeding as low. So this again is not an agency conflict. He decides not to pursue the investment for an objective reason that it has low chances of succeeding. So again, here his decision is not self-serving. It's simply a proper decision to take. Sue instructs her staff to keep safety inspections in one of the company's factories, knowing that it will likely fail the inspection and incur significant costs to fix. So this is a weird one because obviously this is wrong, what she does, instructing the staff to skip safety inspections and thus avoiding the cost. This is definitely not ethical decision and like completely incorrect from the point of safety. It's not an agency conflict because I guess maybe it could. Okay, I'm unsure about this one. I'll definitely double check before I put something like this in your final. But on one hand, it seems that she's doing this so that the company doesn't incur the costs, which of course would benefit the shareholders if they avoid the cost. On the other hand, if this comes out, or even worse, if something dangerous happens to one of the employees, that's a huge liability for the whole company. So, I guess this is just an example of a bad situation, not necessarily an example of an agency conflict, although I do realize this one is a little bit weird. Alright, let's look at the last one. Bill chooses to pursue a risky investment for the company's funds because his compensation will substantially rise if it succeeds. Okay, so this is kind of a clear-cut agency conflict where he decides to go ahead with a risky investment, and he does it primarily not because it's good for the company, but because his own compensation will go up. So this is a classic where a manager takes a decision that's supposed to benefit himself versus the company. So for question 1, the clear answer is D. Let's look at question 2. A manufacturer of breakfast cereals has the opportunity to purchase barley at $3 a bushel for 10,000 bushels if it also buys 5,000 bushels of wheat at 16 per bushel. However, the manufacturer does not use any barley in its products and currently needs 20,000 bushels of wheat. If the current market price of barley is $3.80 per bushel and that of wheat is $15.80 per bushel, should the opportunity be taken and why? So let's compute the value of this opportunity. So basically, let's compute how much he should pay for those items and how much are they worth based on the market price. Right, so let's see what's the purchase price for wheat and for barley, plus the amount, and market price, and we're going to compute the value of this opportunity. Okay, so he can purchase barley for $3 a bushel for 10,000 bushels. If he also buys 5,000 bushels of wheat for 16, and current market price is $3.80 for a bushel of wheat. No, sorry. 380 for barley, and 15.8 for wheat. Okay, so at the first glance, he only needs barley. He doesn't need wheat. Actually, the purchase price for wheat is higher than the market price, so it may not seem obvious what he should do. But let's see. So basically, he can buy. Let's see what would be the net benefit from buying both wheat and barley, and then what would be their market value once he buys them. So if he buys wheat, he's gonna pay for it. Actually, we can look directly what's gonna be his loss or gain from buying. Sorry. So in this case, the market price is 15.80. He's gonna buy it for 16 times 5,000 bushels, and that gives us a loss, right? Because he's buying something for higher price than the market price. So that gives him a loss of 0.2 times 5,000, or $1,000. This is a negative number. Negative. This is a loss. Okay, and from barley, he actually is going to have a gain, 380 minus 3, so 80 cents gain on every bushel times 10,000 bushels. So that gives me 0.8 times 10,000. So that gives me 8,000 bushels. Sorry, $8,000, which is a gain. Okay, so the net gain from this purchase would be 8,000 minus 1,000, giving me 7,000. So even though he loses on the barley a little bit, he's getting such a good price for. Sorry, if he loses a little bit on wheat, this is wheat, he's getting such a good price on barley that this is actually a great opportunity. So going back to our answers, the answer would be A. Because of the value of the opportunity is positive, the opportunity should be taken. All right, let's look at 3. At 8% compounded annually, how long will it take 750 to double? Okay, so this is something we can do on calculator or in Excel. So for instance, in Excel, we're asking about what's the number of years and number of periods, and PER, in a situation where we have 8% rate, there is no payment. The present value is 750, and the future value is 2 times 750. And we're going to set the future value as a negative. Remember always that if present value is positive, future value should be negative, or vice versa when you're trying to solve for number of periods or rate using the Excel or calculator. Okay, so that's our future value, and that gives us around 9. So the answer is 9 years. And of course the same would be on calculator, where you would solve for n by putting 8 as your interest, 750 as your present value, and negative 1,500 as your future value. All right, let's check out number 4. A friend plans to buy a big screen TV entertainment system and can afford to set aside $1,320 towards the purchase today. If your friend can earn 5% compounded yearly, how much can your friend spend in 4 years on the purchase? Round off to the nearest dollar. Okay, so this is a simple future value question. So the friend plans to buy a big screen, he can set aside, the present value is $1,320 today. He can earn 5% compounded yearly, and he plans to keep that investment for 4 years. So, I mean, for example, we can use calculator for this. So our present value is $1,320, no payment. Interest rate is 5%, number of periods is 4, compute future value, and that gives me 1604. We could have also done it, of course, in Excel, where we would use the future value function. So the answer is 1604. Right, question 5. Dawn Swift discovered that 20 years ago the average tuition for 1 year at an Ivy League school was $4,500. Today the average is $29,000. What is the growth rate in tuition costs over this 20-year period? Round off to the nearest percent. Okay, so this is kind of a funny question, because you may think, why is there a growth rate here? But it's actually a question asking you for the interest rate. So when you think about present and future, what is the difference between present and future value? Well, future value is present value to which interest rate has been applied, and interest rate is basically telling you what is the growth rate of your money. So here, when we're asking for growth rate, we're actually asking for interest rate. So we can use Excel to solve it using just our rate function. So we would ask for rate, where number of periods is 20 years. There is no payment. Present value, so I'm going to do 1 negative, 1 positive. So let's say present value is negative 4,500. So future value would be 29,000. And let's see. And I see the rate here is 10%, but this may be rounded up. So I'm going to look more precisely. 9.76. Or with 1 decimal, 9.8, which is one of the answers here, answer A. Question 6. Your company has received a $50,000 loan from an industrial finance company. The annual payments are $6,202.70. If the company is paying 9% interest per year, how many loan payments must the company make? So here we're basically asking for the number of periods. We can solve it with Excel, we can solve it with calculator. Maybe we can try calculator this time. So your company has received a $50,000 loan. So $50,000 is our present value. From an industrial finance company. Annual payments are $6,202.70. And those are negative numbers because those are our cash outflows, payments to pay back the loan. The company is paying 9% interest per year. How many loan payments do they need to make? Compute N, and N is 15, which is answer B. Okay, and let's take a look at question 7. Francis Peabody just won the $89 million California State Lottery. The lottery offers the winner a choice of receiving the winnings in a lump sum or in 26 equal annual installments to be made at the beginning of each year. Assume the funds will be invested at 7.65%. Francis is trying to decide whether to take the lump sum or the annual installments. What is the amount of the lump sum? That would be exactly equal to the present value of annual installments. Round off to the next dollar. Okay, so this assignment is a little bit complicated. I mean, it's not complicated, it's just phrased a little bit weirdly, and it has a couple of tricky moments. I also want to remind everybody that sample exam is supposed to show you the type of questions you can expect, but usually also would have a little bit harder types of questions that allow me to discuss more complex versions of what you can expect. The assumption is if you understand the more complex version, you should have no problem with a little bit easier version on the midterm. So there are two things we have to notice. Well, first we have to figure out what we're looking for, and we're looking for a present value of annuity, and the annuity is 26 equal payments that will add up to 89. So basically the lottery is stated in a way that you can get $89 million in 26 equal payments, so that implies that each payment is 89 million divided by 26, which is a payment of about $3.4 million. Now, the other important part is that it says there at the beginning of the year. So this is the type of annuity that we haven't covered in detail. It's called annuity due. So usually in our annuities, our payments would be at the end of the year. In this case, the payment is at the beginning of the year, so it affects how we compute our interest, because that first payment starts earning interest immediately and not after the first year. We don't need to know the equation for annuity due. We can just break this annuity into two sections. So the way I would do it is I would break it down into this one payment that's just happening. So first part would be payment at time 0. And that payment is equal to 3.4 million, right? And that payment, I mean, it's not gonna have any interest attached to it because we're looking for present value. That payment is already in the present, so we can just leave it as it is. And the second part would be present value of annuity that consisting of 25 payments, right? Because we already took care of one of those payments. 25 payments of 3.4 million each, and all those two things together will give us the present value of annuity. Okay, those two things will add up to the present value of annuity. So this is what we're looking for right now. Okay, so what do we have? So basically, we're going to focus now on finding part 2. Present value of annuity of 25 payments. Each payment is $3.4 million. The interest rate is 7.65%. And the present value, we're going to use our present value function, where the rate is 7.65. Number of periods is 25. Payment is 3.4 million. Future value is 0. Type is 0. And this would be our present value. We can put a negative sign before PV, and this will show as a positive number. So now the present value of the whole lottery, so lottery payment, lump sum lottery payment today. As I mentioned, it's a sum of present value of annuity plus that first payment of $3.4 million. And the whole thing is equal to $41 million, more or less. 41,083,127, or 128 actually after rounding, which is answer C. Okay, of course, I mean, at the exam, you won't have annuity due with payments at the beginning of the year. You will have a regular annuity, so you don't have to worry about that. If some of you are interested, or maybe I'm assuming some of you may have noticed that actually your present value formula has an option for annuity due. So if you wanted to do this whole thing in just one equation without separating that first payment, you could do that as well. So it's present value, and then of course our interest rate 7.65%. Number of periods, in this case I'm typing all of them, 26. Payment, so it's $3.4 million. Future value 0, and then type, as you can notice here that we always choose type 0, which is end of the period, but you can choose type 1, which is beginning of the period. And let's see what happens. And indeed we found the exact same answer as above.